So hello everybody. Today, to start this session of presentation, we will start with our project, which is on fluorescence spectroscopy for dermatology. So what is at stake in dermatology and the optics? There is some skin disease that is named actinic keratosis, which has a high incidence rates, and that we studied in our project. So this disease of the skin can lead to skin cancers, and it affects in Western countries approximately 30% of the dermatology patients. So there is some statistics on this disease.
But fortunately, today more and more technologies are being used to help to cure this skin disease, and one of them is spectroscopy. So it's a non-invasive way to study the way the light interacts with skin's molecular components. So we have access to these molecular identifications, and then we can assess a very personalized treatment to the patient.
So in our project, we use a lot of spectrum. So a quick reminder of what is a spectrum. So it's a physical representation of the light with the distribution of the light in function of its wavelengths. So it will be really useful in the rest of our presentation. Our project is based on the photodynamic therapy of skin cancer. So it is how we treat cancer with light. How it works. We applied a cream on the tumor, on the skin, and this skin will increase the production of one molecule in these tumors, which is named the protoporphyrin 9, and this molecule is really important because it has two main properties. The first one is that it transforms the light, the light into energy that will kill the tumor, and that's what we want to kill the cancer. And the second property is what we will use in our study. It's the fluorescence of this molecule, the protoporphyrin 9. What is the fluorescence of this molecule? So fluorescence is the fact that this molecule will absorb the light in one part of the spectrum, so in one part of the light, and will emit it in another part, and it will allow us to make a study on its proportion in the skin.
So basically, this is how it works. The patient arrives at the hospital, let's say in the morning, and we do a first acquisitions by using a probe which is connected to a PC where we have a software that is used to do all the calculations. So after that, we apply a cream on the wound, and we let the patient rest for, let's say, a few hours. And after that, we enlighten the wound, and we regularly come back to do new acquisitions. After that, everything is uploaded on a database. So this is what the first graph is, what the raw data do look like. And when we merge one curve, for example, this one, we have two interesting things here. The peak in the center shows us the amount of protoporphyrin 9 we do have in the skin. So the first work we do we have to do here is to fit the exponential here and then to delete it for each, we have to delete the exponential for each curve. And after that, we integrate it and we do the same process for each curve, which gives us this, when we plot it, this graph, which is the amount of protoporphyrin 9 in function of the time. Here, for example, the condition 0, it's before applying the cream. And after that, we can notice that after the condition 1, so when we start to put some light on it, we can see that we have less and less protoporphyrin 9 in the skin, which shows that this method is working very well. So, and even for the conditions 3, 4, and 5, it's close to 0. So it's very effective here. However, for some other patients, we have a lot of points which are very close to 0. So it was not working so well. And we have some theories to explain why. The first one would be that the cream was not applied very well because they have a process to apply the cream on the wound, and we can think that it was not done so well. The other theory would be that the cream was applied on the wound scab, which means that it wasn't able to penetrate properly into the skin. So there are two interesting feedbacks, and we think that by taking it in consideration, we can improve the efficiency of this method and help way more people with their skin disease. Thank you for your attention.